Okay, we're on to the last two examples for this. So part A, you should just check your answers real quick. So the cost to remove 85% of the pollutants would be $453,000, $333.33. So that's the 85. And the 90% is $720,000. Okay, so you should check your work, make sure you plug those in correctly. And now, what's the vertical asymptote? Now, before we get to that, I want you to think about why is there a vertical asymptote in this? Why can't we remove all of the pollutants from the air? Okay, I want you to think about this, maybe talk to a neighbor for a second, pause the video, and come back. So now you should have paused the video and talked to a neighbor about why is there a vertical asymptote. Well, think about how hard would it be to remove stuff from the air. Like, it's going to get really hard the more you have to remove from the air. So we've got that vertical asymptote because it would just cost infinite amounts of money for us to remove every single little tiny pollutant in the air. And this is why it gets more expensive, because the more you remove, the less there is to find, and it gets harder and harder to find. So that vertical asymptote is at 100%. So we answer that question, what does it mean? It costs way too much money to find all those little tiny pollutant particles in the air and remove it. It would just be way too much money. So it would cost infinite money to remove all pollutants. Okay, so now let's move on to the next problem. So I like this one a little more. It's a little more interesting. So the first thing is it asks you to come up with an equation. And so on this one, it is in the little box in the bottom right. So it'll be 20 over x, because they want to travel 20 miles. And we're dividing it by our velocity, distance divided by velocity. Okay, and then we're going to add the return trip is 20 miles as well, but now your velocity is x minus 10. Okay, so your velocity in your return trip is 10 miles an hour less. Okay, but now we're going to have vertical asymptotes in this problem. Okay, those are going to be at, I'm sure you can see, at x equals 0 and x equals 10. But the big thing I really want you to think about is, what do those mean? Why do we have those vertical asymptotes there? So I want you to really think about this. You know, if you haven't answered this, just double check, think about it for a second, pause, talk to a neighbor, and then come back. So now you should have talked to a neighbor about, what do these asymptotes mean? Okay? Well, if your velocity was 0, so 0 velocity, you wouldn't be traveling, you wouldn't move. Now my pen's acting up. So you wouldn't move. So why do we have this vertical asymptote at x equals 10? Because on the return trip, you're going 10, your velocity is 10 less than on your other trip. So if you don't at least have a velocity of 10 miles an hour on the trip outgoing, then you're going to have 0 velocity on your way back. So your return trip would have 0 velocity. So if we're looking at that graph that we've got down here in the corner, I'm going to highlight it in orange, but we see that we've got a part of a graph from 0 to 10. Okay, so I'm just going to draw that asymptote in right there. So we've got a part of the graph. But does that graph actually help us? Is it possible to have any of those velocities? Because think about this. What if you had a velocity equaling 8? On the return trip, you would have 8 minus 10, which equals negative 2 velocity. So how are you going to get back if you're going backwards? You have a negative velocity. So for this one, you need to be careful, and you actually can't use any part of this graph. So you need to know that your x needs to be greater than 10. So the only valid part of the graph is anything farther or to the right of this vertical asymptote.